Hi everyone, so we're going to be looking at energy involved during reactions. So there's two kinds of reactions that can take place in terms of energy. One reaction is where energy is given into the surroundings, and this kind of reaction is called an exothermic reaction. So exothermic, exit, so heat is given into the surroundings. So any form of combustion reaction, any form where heat is evolved, where the thermometer is going to detect a rise in temperature, is exothermic. So heat given to the surroundings, whenever we use a thermometer, the thermometer will detect the temperature of the surroundings. So heat given to the surroundings, so the thermometer will show a rise in temperature. Let's take one example of exothermic reaction. So combustion is one example of exothermic reaction. So let's see the burning of wood. So wood is going to burn, and at the end we're going to have ashes. So initially the wood has a certain energy. Let's represent this energy. So let's say that this is the energy level of the wood. So I have a graph here where the y-axis is showing the energy and the x-axis is actually showing the reaction progress. So I have this level here which is indicating the initial level of energy of the wood. Now as we are burning, what is happening is that energy from the wood, all the energy from the wood, or most of the energy from the wood, is being given to the surroundings, and it's given as heat, as light, and this makes the temperature go up. So we have a fire, energy is given to the surroundings. Now once the reaction is over, we have ashes that is left. Now we know that wood has chemical energy. The chemical energy will be converted to heat and light. Now whatever is left here, the ashes will have less chemical energy as compared to the wood. So we can draw the level of energy of the ashes of the product. So the ashes will have less energy. So what has happened is that the energy of the system has decreased, and we have an energy change that is happening over here. So that energy change, we can easily find it by doing the final energy, so energy of the ashes, minus the initial energy, the energy from the wood. Now in science, energy can be represented by H, energy, and change is represented by the symbol delta. So energy change can be written as delta H. Okay, now the final energy, so energy is represented by H, so the final energy is going to be HF, and the initial energy is going to be HI, heat or energy initial and energy final. So delta H can be given as H final minus H initial. And because the final energy is lower than the initial energy, so when you have a small number that you're subtracting a larger number from it, the result is going to be negative. So delta H is negative for an exothermic reaction. So delta H is the energy change. Energy change is negative when you have an exothermic reaction. Now this little diagram here, this is called an energy level profile diagram, which shows the energy levels of the reactants and the products. So here the energy of the system is decreasing, as you can see. So where is that energy going? It is going to the surroundings. So this is all for exothermic reactions.